So, anytime you see that dot H2O, it means you have a hydrate. Think about it, water, it's hydrated. It's just like saying you have that many water molecules attached to your main piece. And like I said, in lab, you guys are going to calculate the percent water in this compound next week, provided that I have the chemicals come in by then. Otherwise, we'll do it a little bit later in the year. But that's what it looks like. So you've got to account for 5 whole water molecules when you do the molar mass. So if I write it out like I did here, copper, sulfur, oxygen, not hydrogen, water. How many of those do I have? How many coppers do I have there? 1. How many sulfurs do I have? How many oxygens? Now notice, I see oxygen in 2 places, correct? If I write water as H2O, am I going to count how many water molecules, or excuse me, oxygen atoms I have in that? No, I'm only going to count the 4 right here. The other 5 would be with this water portion. Okay? The other 5 would be right here. How many water molecules do I have? I've got 5. So that's taken care of it. Does that make sense? And I went through that kind of quickly. Then I'm going to just go ahead and I'm going to multiply by all those. Copper's what? 63.545, I think. Sulfur's about 32. Oxygen's about 16. Water now. Now I've got to do a molar mass within a molar mass problem. Oxygen, guys, is about 16. Hydrogen's about 1. So when you do that, it's somewhere about, not 16, it's about 18. Then you would go through that same process and add it all up. I believe when you go and do that, it should be somewhere about 249 grams per mole. You guys go ahead and do the calculation right now. All right, if not, we're going to go on. Yesterday, we started talking about it. We did some practice. We can now use molar mass of compounds as conversion factors as well. We did this with single elements. We did it in the pre-lab last period, where you guys took the mass of calcium, right, and we figured out how many moles were in it and then how many atoms you had in a certain number of grams. Same idea here. We can use those as conversion factors. You just now have to go a little step further. Instead of just looking at your periodic table, to get the mass of a single element, you've got to add up all of those. So what I want you guys to do right now in your notes, at the bottom of page 4, I want you to go through and figure out how many moles you have in 127 grams of barium chloride. Here's a hint. What's the first thing we have to do to be able to solve this problem, besides writing down our given? Find the chemical formula. That's the first thing you have to do. So see how it all comes back together. Unit 5 plays a part in everything that we do. This is typically how you will see a lot of questions in your future, where I give you the name, you have to tell me the formula. Take a couple minutes, go ahead and do it.
If there's 2 chlorides, we have to do the molecular mass twice, right?
Absolutely. Multiply it by 2. It's barium 138. I was going to say 137. Point what? 33?
Yeah.
So your molar mass you should have of this is right around 208. I'm just going to round just for the sake of time. So you guys go more specific. I'm just going to show you how to set it up. How many steps should our conversion be? What are we trying to get to? So we're using that mole roadmap. Yeah, we're going to make one new fraction. So you're going to see 2. So your T-chart's going to look like this. Grams of barium chloride will be on the bottom. Moles, make sure you get in that habit now in this unit of writing down your substances with your units. If you just write down grams or moles, I'm telling you, you got to trust me on this. When we come back from Christmas break and we do stoichiometry, if you just write down moles or grams, you're going to get confused. Okay, because we're going to be dealing with multiple substances within one problem, and you will get confused. So, mole on top, molar mass on the bottom, it's about 208. 127 divided by 208. What do you get for a final answer? How many sig figs should we report our final answer to here? How many did we start with? 3. Syntax error, that's not good. Was it 611? 610. 611. 611, 610, guys. Either way you round it, I'm not going to take off for that. Okay? Again, it's going to depend on what, if you rounded your molar mass of your substance before or if you kept it out. That could be the difference there. So I'm not going to mark it wrong if you put down 0.610 and I said it's 0.611. That's a thousandth of a gram. I'm not going to mark you wrong. I'm just going to say, hey, do you have 3 sig figs? Is it basically the same number? That's what I'm looking for. Easy? Okay, we're going to do a lot of practice tomorrow in class. The whole period will be devoted to practicing these because we have our quiz on Friday. All right, our molar calculation quiz on Friday. We're going to do practice with that tomorrow to prep ourselves for it. All right. So today, what we're going to talk about, not page 5, go to page 6 in your notes. We are going to talk about percent composition today. That is our next topic, and to do that, I love doing this lab every year. This little activity. We're going to calculate the percent sugar in a piece of double bubble gum. All right? Now, if you can't chew gum because you have braces or something like that, don't do it. But I'm just saying that I'm on record to saying that. It's your choice. I can't tell you. I don't know. It's on the internet. What you're going to do, don't do anything with it yet. Actually, I'll pass it out to everybody individually. We're going to figure out how much sugar is in a piece of gum. I'm going to do this with you as well, and I know I probably shouldn't do it while I'm teaching, especially because I'm being recorded. Oh well, I want to be part of the data as well. I don't know. We'll see. All half period. All right, and here is the lab sheet that we're going to put with it for our data. Again, if you can't chew it, don't ruin your braces.
I haven't chewed them.
Am I really?
This is going to be the second
I talk. All right, let's start talking about percent composition. So in your notes, highlight, underline, whatever you want to do to have it. Percent composition, when we talk about it, it's the percent by mass. That's our key piece here. By mass of each element in a compound. So when you're asked to do percent composition, fortunately for you, you guys have this formula in your reference packet. Take a look. I think it's the last table in your packet, very last page of your reference packet. Flip to that right now. Table T. It is the 4th one down on your list. So you don't have to memorize this. Anytime you're ever asked to calculate a percent of anything, it's always part over whole times 100. So percent by mass of an element, the part is going to be the element you're looking for. The whole is going to be your entire compound's mass. So one thing that's unique about percent composition, guys, is that it's the same regardless the size of the sample. This goes back to way back in Unit 2 when we talked about the law of multiple proportions or definite proportions. It's the same no matter you have one molecule of water or you have an ocean full of it. It's the same regardless the size of the sample. So this is what our formula looks like. The mass of the element divided by the molar mass times 100. You're going to do that for every element. Super, super easy. First things first, we want to find the percent composition. If it just asks you that in general, you're going to tell me the percent of each element in your compound. What's the name of this compound? I'll give you a prize if you can tell me correctly the name of this compound. Step 1 is to find the molar mass of the entire compound. If you write it down like I showed you yesterday, it's going to make your percent composition calculation very easy. So I've got copper. I've got sulfur. How many copper atoms do I have? 2. How many sulfur atoms? What's the molar mass of copper? What's the molar mass of sulfur? That math is pretty easy there. What's 2 times 63.546? You all have calculators. Plug it in.
127.092.
All right. That's our first part for that. Add them up, right, because it's the sum. Get the total. 127.092 plus 32.065. What is our molar mass total? This is where you've got to show all your work for molar mass. If you just put a number down on your paper, on your quiz on Friday, I'm going to mark it wrong. You've got to show me your work. Go ahead, Maddie.
159.157.
Okay. That's step 1 is finding our molar mass. We've done that. We did it yesterday. It's easy. Now, step 2 is where we're going to find the percent of each element. So I'm actually going to go back here. Notice how I have it written on my work, how I have my work written here. What is our formula for percent composition? Part over whole, right? The mass of the element divided by the molar mass of the compound. If you wrote it down like I have here, notice down here, that's already set up. All I have to do is add a times 100 right here. That's my calculation for percent composition. It's my part sulfur, the top part, over the entire molar mass of my compound times 100. So all I have to do up here then to show my work is put 159.157 on the bottom and times 100 and equal it. So if you do that kind of front-end work by, good note-taking, showing all your work for your molar mass, it sets you up for percent composition to be a piece of cake. All right, a piece of cake. Go ahead and do the math right now. Hunter says sulfur is what? 20.1%. Who can tell me what copper is?
79.8%.
Okay. That's it. That's our percent composition calculation. Step 3, check your work. Does it add up to 100? Now, does it have to add up to 100 exactly? If it's 99.9, if it's 100.1, that's okay, because remember, you're rounding. So sometimes when we round, it's not going to be exact. But that's it, guys. That's our percent composition formula. That's all it is. It's just one extra small step from calculating molar mass. Super, super easy, right? Not too bad. And you don't even have to memorize the formula because they give it to you on Table T in your reference packet. And make a side note on your reference packet. That can be used anytime you're looking for any percent of anything, part over whole times 100. So if you're a baseball player, what's your batting average? How many hits over how many at-bats you've had? If you are calculating grades, how many did you get right out of how many total points could you have gotten right? That's how we calculate most averages of anything. Part over whole times 100. All right, we've been chewing our gum for about 5 minutes or so. We're going to go back and finish this lab right here, this activity.